If you look at problem 51, it's a topic I already explained in the previous lecture. This problem asks what kind of change must occur in two structures for reflection to happen. I've previously explained that the keyword most closely related to reflection is the difference in acoustic impedance. So you should choose option C, which contains that keyword, as the correct answer. If you are familiar with these related keywords, you can quickly and accurately find the correct answer without even having to interpret the question, which is a significant advantage. Next, let's move on and look at question number 52. Looking at the question, it asks you to select the option that corresponds to a specular reflector. First, let's look at the answer sheet to see what specular reflector means. According to the main text, a specular reflector refers to a change that occurs at a large, relatively smooth interface. For example, you can think of structures like the renal capsule or the diaphragm as places where these phenomena can be observed. It is also noted that specular reflectors are characterized by appearing bright on imaging. To put it simply, this refers to changes that appear bright because the ultrasound beam is well reflected from smooth and broad areas. The correct answer is the renal capsule. Because the capsule structure surrounding the outside of the kidney is smooth and sleek, you can consider it a specular reflector. I think it will be more helpful if you review the explanations like this and organize the content. So please check the renal capsule listed as the correct answer in option A. Let's look at question number 53 right below. This question was also explained in the previous lecture, so let's go straight to the answer. To reduce attenuation, you can simply lower the frequency and the attenuation will decrease accordingly. Next, let's move on to question number 54. If you look at the main text, you'll see the term breast cyst. It can be interpreted as a breast ultrasound examination in which a cyst was observed. Shadowing is being observed, and there is an additional explanation that the shadowing appears at the lateral border. This kind of shadowing being observed is a question asking what causes it and from what source it arises. Let's take a look at the picture first. In this way, a cyst can be observed on a breast ultrasound examination. In the very center, you may see posterior acoustic enhancement behind the lesion. On the other hand, at the lateral border on the edge, you may observe characteristic shadowing that appears as a dark area. This part, as mentioned in the previous explanation as well. At the lateral border, you should understand that it is related to the phenomenon of refraction. It would also be helpful to remember that the phenomenon of refraction is related to differences in speed or to the fact that the angle of incidence is oblique. Additionally, since shadowing occurs on the lateral side, you should also remember that it affects lateral resolution. Based on this information, let's look at the main text again. If you look at the sentence, since it asks about the mechanism by which shadowing occurs, you just need to find keywords related to refraction. The correct answer would be to choose the option that mentions propagation speed and a curved surface. So, as long as you clearly understand what is essentially being asked, this is a pattern you can solve without much difficulty. Next, let's move on and look at question number 55. If you look at the question, it can be interpreted as waves combining. The expression here has a mathematical meaning, but it's not a word you really need to know in detail. So this is a question where you need to find the concept related to the combination of waves. The correct answer is interference, which is option B. Let me explain this with a diagram. If you look at the diagram, when two waves combine, you can observe two types of interference. So in Korean, this expression is called destructive interference. Here the term constructive interference is used. When two waves meet and cancel each other out, that's called destructive interference. On the other hand, when their energies combine to form a larger wave, that's called constructive interference. The main idea is that two waves combine, so you can think of it as referring to interference. So the correct answer is interference, choice B. Now let's look at question number 56 right below. This question is related to question number 55. In echo interaction, you are looking for the keyword related to the phenomenon where mutual interactions lead to reinforcement. The keyword related to the phenomenon where the forces become stronger rather than partially or completely disappearing can be considered A. As I just explained, when two waves meet and their forces increase, the term associated with this is constructive interference. Next, let's move on to question number 57. In the case of this question, it could add confusion to concepts you already know, so I would say there's no need to look at it. For something like a rough surface, since it's a coarse surface, scattering occurs in this context. Even though these two concepts are related in the actual SPI exam, in this question, the correct answer is given as option C. Of course, these concepts are also related, but since they can further confuse the concepts you've actually studied, you don't need to solve this question. Just remember separately that if rough surface comes up next time, it's more closely related to scattering. Not every question is important like this. Just keep in mind that there are also things you need to filter out. Let's look at question number 58 next. This question can be easily solved by associating it with the relevant keywords. When a sound beam passes through, small aperture means a small opening. When a beam passes through a small opening, the phenomenon is called diffraction. The correct answer is diffraction, which is answer C. Also note that the sentences here are related concepts. Next, let's move on to question number 59. Similarly, since this was mentioned earlier, let's go straight to the answer. This question is asking which sound parameter is determined by the medium. The propagation speed can be determined by the medium, so the correct answer is D. Next, let's move on to question number 60. Let me emphasize first that this question is important before we proceed. This question asks you to find the statement that best describes Snell's law. First of all, the main thing you should recall about this law is that it relates to refraction. This law is directly related to refraction. Given that, there are two possibilities that could come up. The two conditions under which refraction can occur are oblique incidence and the difference in propagation speed. So, if you find an option that includes these two concepts or is related to refraction, you can say that it describes Snell's law well. The correct answer would be option B. There are two clues included. It involves oblique incidence and a difference in the two propagation speed. In subjects like physics, rather than trying to understand and grasp every detail, it's also a good problem-solving strategy to look for related keywords.